Everyone, I am Bhagilakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about Lagrange's linear partial differential equations. Based on this, we move on to the first sum. So the first sum, in this model, we can identify the model like PP plus QQ equal to R. So PP, the coefficient of P is P and the coefficient of Q is Q and right side value is called as R. So based on these three values, we can write the subsidiary equations. Dx by P equal to dy by Q equal to dz by R. So instead of P, Q, R, we can write. And then each and everything is in the equality condition. So I am taking first two ratios first and then last two ratios. So first two ratios and last two. First two ratios, dx by x equal to dy by y. Integrating on both sides, we get log x equal to log y and one more, and log x equal to log y plus log c1. So based on that, one constant will exist. So log c1, we can name it as log c1. Taking the functions in the left hand side and the constant in the right side. Log property used means we can write it as log of x by y. So cancelling log terms, x by y equal to c1. So instead of this c1, we can name it as u. So we got the final solution u equal to xy. Same thing we can do it for the second solution. Taking last two ratios, dy by y equal to dz by z. Integrating both sides, you get log y equal to log z and one more constant. Name it as c2, log c2. So take the functions in the left hand side and constants in the right side. Using log property, y by z, log of y by z equal to log c2. Cancelling the log terms, you get y by z equal to c2. And instead of this c2, we can name it as v. So finally, u and v values we got. The general solution we can write using these two. The function of u comma v equal to 0 is the general solution for this type. So instead of u and v, we can replace this. It is got the solution. So based on this, the next sum is also same for these terms. Instead of the right side value, previous sum z is given, here x is given. So same model only. So I move on to the next sum. The next one is p tan x plus q tan y and which is equal to tan z. So from this pp plus qq equal to r. So p from this so p tan x p value, q value and r value we can write. So p value in subsidiary equations, p dx by p, dy by q and dz by r. From this p, q, r values we can write. Each and every term is equal. So I am taking first two and the next two ratios. So from the first two ratios we can write. So first two ratios, if we choose dx by tan x and dy by tan y. This 1 by tan y we can write it as cot x. So this cot x dx, cot y dy. Integrating on both sides, we got integrating cot x is log of sin x. Integrating cot y is log of sin y. So the constant also we want to write it as log c1. So log of sin, these two are in positive terms. So I am combining log of sin y into c1. Sin x equal to sin c1. Whatever it is, like previous sum, if we choose the same answer only will come, sin x divided by sin y equal to c1. So next, instead of c1 we can note it as sin x by sin y. Again the same procedure we are proceeding, last two ratios. So the last two ratios if we choose in terms of y and z is given. So 1 by tan y we can write it as cot y and 1 by tan z we can write it as tan z. Integrating on both sides, log of sin y and log of sin z. So same thing, log of c2 is existing here. So multiplication for the addition log property, we can write it as a multiplicative term and then c2 equal to sin y by sin z. So from this c2 we can write it as sin y divided by sin z. The general solution for the given equation is f of u comma v equal to 0. that is sin f form sin x by sin y comma sin y by sin z which is equal to 0. Thank you.